So this is the very end of the section 4.1 notes, and the last thing that we didn't do was find the annual percent yield. So APY stands for annual, oops, which I didn't spell right, percent yield. And what that means is the bank is required to tell customers the actual percent you would earn on your investment over 1 year, because the compounding frequency affects how much actual interest you earn. And we talked about that the other day. So here's how we calculate it. So let's do it for an example. So if we had 6% compounded daily, and we want to find the annual percent yield. So watch this. If I calculate I have a P, but I'm not going to write it down for now. I would do 1 plus the interest rate written in decimal form divided by the number of compoundings in a year, all raised to the n, which is 365, and we're doing 1 year because annual, so 1 year, so times 1, which I obviously don't need. And I only actually care about the rate, so I'm not going to put a P out here, or it's like P is 1. So I'm just going to get the 1 plus the rate. So if I simplify this, so just type this into your calculator, it turns out that we end up with 1.06183. So that's the 1 investment times the 1 plus the rate. So how does that compare to simple interest for 1 year? So simple interest is A is equal to principal times 1 plus R. No compoundings, just do it for 1 year. So if I do the same thing for 1 year, my expression would look like 1 times 1 plus R. So we did the calculation for one investment, $1, for 1 year at 6% compounded daily, and we got this. And how does it compare to what the simple interest would be if we did it for a year? Well, 1.06183 would have to equal the 1 plus R. So subtract 1 from each side, and we find that R is 0.06183, or in other words, the annual percent yield written in decimal form is 6.183%. So if you do actually want a formula, the rate would be, we got it by taking this expression and then subtracting the 1 to get the corresponding R for a simple function. So it would be this expression, which is 1 plus R over n to the nt, and then subtract the 1, so if you really want a formula. So now we're going to move on to the 4.2 notes. So the next page. So we're talking about the natural exponential function. So first we have to start with the natural number, which we call e. So e is defined to be 1 plus 1 over n to the n as n approaches infinity. So in other words, to calculate e, you would plug in gigantic numbers for n, and you would get closer and closer to the true value of e, and e is approximately 2.7. So we're going to talk about the exponential function e to the x, which we've actually seen before. It is exactly an exponential function with a base that just happens to be e. So if you want to know how to do it on your calculator, if I want to find out f of 3, I would put in e to the 3 and type it into my calculator, and it turns out it's 20.086. And you do that by the ln button along the left of your calculator. Above it, it has e to the x, so you do shift ln button to get e to the x, and then it pops up with e to the little empty box, and you type in your 3 and hit enter, and that's what you get. Let's also calculate e to the 0, because we're going to graph it in a second. So anything to the 0 is always 1. So as we would expect with an exponential function, the y-intercept is at 1, and then the general shape of an exponential where the base is bigger than 1 is like this, so that's what we expect. So now you're going to try an example. So take a minute, read the question, do A, B, and C, pause the video, and then come back and we'll see what we got. So now that you've had a chance to do example 3 and come back, look at A. At time 0, how many infected people are they? So you would put 0 in for the t, and then you would type it into your calculator and be really careful. You need lots of parentheses because it's really important the entire denominator stays as the denominator. And hopefully you found that you got out 8 for V, which is the number of infected people. And then part B says find the number of infected people for 1 day, 2 days, and 5 days. So you do the same thing several times. You could do that in the table function in your calculator, or you could do it once, 3 times. And you would find that on day 1 it's 21, on day 2 it's 54, on day 5 it's 786. So clearly more and more people are getting infected at a very rapid rate. So to graph V, you definitely don't want to do it by hand, so either calculator or Desmos. And if we graph it, it looks like this. So if I go from 0 to 12, it gets big really fast. And if I make my y values go up to 3,000, it shoots up to 2,000, and then it kind of levels off. And this is around 8 days, 8-ish days. So it shoots up rapidly between 0 and 8 days, and then it levels off at 2,000. So that's the answer to part C. And then lastly, continuously compounded interest. You probably did this before as well, but if not, very similar to compound interest, all the variables mean the same thing. P is principal, the initial investment. A is the value of the account after time t. R is the interest rate in decimal form, and T is the time in years, and E is E that you use on your calculator. So if we wanted to find the value in an account earning 12% interest, compounded continuously after 3 years, and I forgot to tell you that we're starting with $1,000, so we needed to know how much we started with. So you put it in, A equals P, 1,000, times E to the exponent 0.12 times 3, make sure that's all up in the exponent. Type it into your calculator and you get $1,433.33. And you can compare that to the problems that we did the other day in section 1, where we were compounding with different compounding frequencies, and see if it's in the same ballpark. And then make sure you do these only for homework problems.